3.
Assalamualaikum and a very good day. So today we are group 1 presenting about tidal energy, which is located at Sehwa Lake, South Korea. So our group member is Nur Fatin Nazira, Nur Hafiza, Trina Jiha, me Muhammad Nabil and Zafran. So for first chapter we are going to talk about introduction, which is what is tidal energy.
So what is tidal energy? Tidal energy or tidal power is one of the form of renewable energy, and it is happening when tidal action in the oceans is converted to electric power. Tidal energy is created during the rise and fall of tides by the surge of ocean waters. According to Marquez et al., tides is happen due to gravitational force by sun and the moon. Why we use tidal energy? Tides are the most predictable renewable energy source. Contrary to wind and sun, tidal currents are 100% predictable and a very reliable estimation of the total output from a tidal energy power can be easily made. Tidal energy is highly site-specific, requiring economically viable average tidal differences greater than 4 meters and often favorable topographical conditions such as estuaries or certain types of bays. These are one of the examples of the tidal power. It is located at La Rance, France. The Rance tidal power station is world's first tidal power station and also the world's second biggest tidal power station. The facility is located on the estuary of the Rance River in Brittany, France.
The advantages and disadvantages of tidal energy. For advantages, first, renewable. Tidal energy is a green energy source which ensures the energy does not deplete the way it is used. So, when you take advantage of energy from shifting tides, you are not going to minimize the amount of energy that tides will generate in the future. Second, zero carbon emission. Tidal power station does not release greenhouse gases during the production of electricity because greenhouse gas emissions are one of the leading causes of climate change. Third, predictable energy generation. Tides currents are extremely stable. Low and high tides obey well-known patterns, making it easy to know when electricity will be generated all day long. It also makes it possible to know how much electricity the turbine can generate, since the power of the tides and currents can be precisely forecasted. The last one, high power output. Tide power stations are able to generate high quantities of electricity. Even though the water travels at low speed, the density of water enables the turbine to be powered. Thus, tidal turbines have the ability to generate significant quantities of energy, even though the water conditions are not optimal. The disadvantages of tidal energy are, first, limited installation site. Tidal energy power needs to be situated on a coastline that confines future station site to coastal state. Besides that, tidal power station also need to be installed in area where the difference in height between high and low tide is large enough for turbines to work. Second, expensive. Tidal power is high upfront cost. Owing to the high density of water, the tidal energy turbines need to be much heavier than the wind turbines. The cost of installing a tidal power plant varies depending on the type of technologies they use. Third, environmental effect. The tidal barriers have a much bigger effect on the coastal climate. Not only do they cause the same issues as turbines do on their own, they also have the same effects that dams do. Tidal dams block the migration of fish and cause floods in the nearby areas that completely change the landscape. The last disadvantage of tidal energy is energy demand. Though tidal power does have predictable power generation, it does not have continuous power generation. We will tell exactly when the tidal power plant will produce electricity, but the electricity production does not satisfy the need for energy. So, tidal power will realistically need to be combined with battery storage to allow the most of the electricity it generates.
Next, method or installation of Siwa Lake. According to Bay et al., Siwa Lake is situated in Gyeonggi Bay in the mid-western area of the Korean peninsula, where the coastline is uneven, hosting several smaller bay and inlet of different sizes and the highest tide in the Yellow Sea. Siwa Lake is an artificial lake of 43.8 kilometers square designed by the South Korean government in 1994 as a land reclamation scheme using a 12.7 kilometers long seawall at Gyeonggi Bay. Based on Cho et al., the main aim of the Siwa embankment's original construction was to secure industrial estate and farmland near the metropolitan area by keeping Siwa Lake at sea level. The annual amount of energy productivity and construction costs for 35 combinations were used to decide the best combination in order to design the layout and optimize the facilities for the Siwa project given that the Siwa lake level is small. To allow dry work, the construction of a tidal power plant (TTP) require temporary circular cell coffer dam. The TTP construction on Lake Siwa is identical to the traditional Lawrence project. The covenant of Lake Siwa were constructed without supporting ranges, and the cell filling alone provide their stability. Due to the water depth and soil condition, while the standard length of a circular cell cover dam 28 meters, the required length is up to 31.5 meters for the Siwa Lake project. At Siwa, the circular cell coffer dam consists of 29 main cell and 28 spandrel wall. The primary cell and spandrel wall are connected by welded distribution pies. With the existence of the control desk, the building of a circular cell was done on offshore. With the existence of a vibrating hammer, the flat section were raised by a crane from a pontoon and pushed to the appropriate depth at the site. First, the silt defense, circular coffer dam, and route of division were installed. The watering and excavation were done for dry work, and then main concrete structure were constructed for power plant and sluices. After unloading from a temporary wharf to the erection bay, the turbo generators, sluice gate were installed. These equipment were then taken to a gantry crane and hydraulic crane by a special carrier. Figure below show the work procedure of the major construction stage.
Okay, next I will explain a little bit about the application of Siwa Lake Tidal Power Plant. Okay, Siwa Lake, as we know it, is the world's biggest tidal power plant that can generate power up to 254 megawatts. According to M. Zaino et al., 30 km per square basins and 25.4 megawatt submerged bulk turbines produce the power of this project. No less than 552 million kilowatt per hour of annual generation power to supply to more than 400,000 residents. It will be replacing of 880 million of imported 88 million of imported oil by reducing 862 million 62,000 barrels of petroleum used annually for electricity production. And Siwalik will give efforts to the tourism industry by securing a space for recreational sports as well as for tidal power plants, and in future it will be born as the hub of the business, future environmentally tour and recreational complex city when Songsan Green City, Siwalik Multi Techno Valley and Universal Studio are developed. So this is the picture of the Sihua station.
So for the conclusion of our case study about Sehwa Lake, next, um, Sehwa Lake Tidal Power Station has helped the people. They are able to access energy to fuel their day-to-day needs easily and at the same time save their finance and use them for developing other sectors. The people need to remember that the reason why the lake is very successful is that the level of pollution in South Korea. Pollution has greatly affected the life of people and should be stopped at all costs to guarantee the quality of the ecosystem that are mainly disturbed by pollution. That's all from us. Thank you.